Ever tried using an augmented reality app only to find the controls too tricky? For millions of people with motor impairments or limited dexterity, traditional AR systems, like touchscreens or controllers, can feel like a barrier, not a bridge. But what if your gestures, not buttons, could control the digital world around you? That's the bold vision of a new study, exploring how deep learning can make AR more inclusive. Let's break it down. Augmented reality overlays digital information onto the real world, right? But most systems rely on precise inputs. Think touch, motion controllers, or even eye tracking. For people with conditions like tremors or limited hand movement, these can be frustrating or impossible to use. This research tackles that problem by building an AR system that learns from your movements. Here's the magic. The system uses wearable sensors and cameras to track your hand and body gestures. But it doesn't just recognize a swipe or pinch, it adapts. Imagine your AR interface shrinking menus, changing interaction modes, or even adjusting sensitivity based on your unique abilities. How does it know what to do? Deep learning models, like vision transformers, temporal convolutional networks, and graph attention networks, work together to decode your gestures. Think of them as a team of experts. One analyzes visual cues, another spots patterns over time, and the third maps relationships between body parts. But there's a twist. Privacy is a big deal here. The system uses federated learning, a technique that trains models on your device without sending your data to a central server. It's like a group project where everyone works on their own copy of the homework and shares only the final answers. This keeps your movement data safe, while still improving the system for everyone. Then comes the real-time smartness, reinforcement learning. This part acts like a personal trainer for the AR interface. It experiments with different layouts, menu sizes, or interaction styles, learning what works best for you through trial and error. If you struggle with a certain gesture, the system might switch to voice commands or simplify the interface, without you even asking. The results? In tests with motor-impaired users, this system boosted task completion by 20% and user satisfaction by 25% compared to traditional AR setups. It's not just about making tech work, it's about making it work for you. So what's next? The researchers hope to integrate even more sensors, like brainwave detectors, and test the system in real-world AR applications. Because accessibility isn't just a feature, it's a revolution. This is more than tech. It's about breaking barriers, one gesture at a time. Stay curious, and let's keep building a world where everyone can interact with the digital future. Imagine a world where your virtual reality experience isn't just controlled by a controller, but by your own body's signals. That's exactly what researchers are exploring. One study uses biological signals, like muscle activity or heart rate, to create interfaces for healthcare VR. Picture this: a patient recovering from an injury could practice movements in a virtual environment, and the system reads their muscle activity in real time to adjust the difficulty. It's like having a personal trainer that feels your progress. But how do these systems understand your movements? Enter machine learning. A 2022 study developed wearable devices that use triboelectric sensors. Think of them as supersensitive skin to detect motion. These gadgets don't just track your steps, they learn patterns like how your hand moves when you type or wave. It's like teaching a robot to recognize your unique style of writing. Now let's talk about decoding gestures. A 2024 study used something called spatiotemporal graph neural networks to analyze electromyography, EMG, data, essentially the electrical signals from your muscles. By mapping these signals in both space and time, the system can predict complex gestures with remarkable accuracy. It's like giving a computer a roadmap of your body's language. But even the best systems need clean data. Motion capture tech, which powers everything from video games to medical rehab, can be plagued by noise. A 2022 solution: an AI called LSD-Net autoencoder that filters out the static, making movements smoother and more precise. Think of it as a noise-canceling headphone for your motion data. And then there's the rise of models that bridge worlds. Take Clip, a system that connects images to text prompts. It's like teaching a computer to describe a photo in your own words. Or dynamic transformers, which make image recognition faster and smarter, perfect for apps that need to process millions of photos in seconds. But what if we could let devices learn without stealing your data? Federated learning, a 2024 breakthrough, lets AI train across devices without sharing sensitive info. It's like a group project where everyone contributes without handing over their notes. Meanwhile, reinforcement learning is making interfaces adapt to you, like a smartwatch that learns your habits to offer personalized tips. Of course, tech should work for everyone. Researchers are designing smartwatch interfaces that are easier for older adults to use, and gesture-based systems for AR that feel natural, not awkward. It's about making technology human-centered, where innovation serves people, not the other way around. The future of human-computer interaction is here, and it's more intuitive and more fascinating than ever. Stay curious, and let's keep building a world where everyone can thrive in the digital age.